Hi everyone, example 3 is pretty much the same thing. So if you want to try example 3 on your own, I encourage you to do so. And remember, you can kind of start deciding, do you want to use your graphing calculator to do this? Or do you want to use Desmos? Or maybe you want to do both. Maybe you like using your graphing calculator for some things and you like using Desmos for other things. So it's kind of up to you. Some people also like to use both methods to check themselves to make sure they did it right. Okay, well I'm going to get started. So let's get this thing graphed. Let's see. Okay, so I'm graphing, which means I need to go to y equals. If you have anything there, you clear it out. All right, so again, if you have a negative leading coefficient, you use the negative button, which I do. So negative 3x squared. And then minus, so now that I have a minus, I don't use the negative button, I use the minus sign. Okay, so be careful. And then plus 5. And oh, I did not put one of my numbers. Excuse me, Sloan. So minus x and then plus 5. Sorry. All right, and then I'm going to hit zoom 6 to give me a 10 by 10 screen. Okay, and then I'm going to graph it on Desmos real quickly. So we have y equals negative x squared. And then, or 3x squared. Sorry, guys. Okay, and then we have minus x plus 5. Okay, sorry about that, I'm being slow. Okay, so first thing we need to find our x-intercepts, which that is where the graph crosses the x-axis. Remember on Desmos, your key buttons when you're finding things on graphs is second trace. Okay, I'm finding a 0, so I'm going to click 2, or I'm going to scroll down and hit enter. Okay, it doesn't matter which 0 you start with. I'm going to start with the 0 on the left first, which first I need to be to the left of the 0, so I'm going to scroll over until I'm to the left of my 0, which currently I am, and I'm going to hit enter. Then I'm going to scroll to the right of my 0, which now I'm above the x-axis, and I'm slightly to the right, so I'm going to hit enter. And then for guess, I'm going to hit enter again. So one of my zeros is at the point negative 0.47 or so. So negative 1.47. Okay, so we have x equals negative 1.47. I'm writing it on my paper right now, so I don't forget, negative 1.47, or the point negative 1.47, 0. Okay, all right, let's find the other 0. So second trace, 0. All right, I need to get my little spider guide to the other side. So first I need to be to the left of the 0, which in this case now I need to be above the x-axis because that is where I'm slightly to the left of my 0. I'm going to click enter. And then I need to go to the right of my 0, so I'm going to scroll to the right and hit enter. And then I hit enter. So my other 0 is at 1.14. So where x is 1.14, or the point 1.14, comma 0. Okay, and let me just double check, 1.14, yep, and negative 1.47. Okay, and again, on Desmos, you just click bam and bam. I have my zeros. So there you go. Okay, so again, these are my zeros, and if you would like to label them on your nifty little graph, which I named this graph Margaret, make sure you guys name your graph. Okay, so this is an x-intercept right here, as well as right here. All right, so now my y-intercept, I'm going to go back to my calculator. All right, so remember how you get to your y-intercept on your graphing calculator. You go to second trace. You're going to click on that value button, which is 1. And then we want to know what y is when x is 0. So I'm going to hit 0 and hit enter. My y-intercept is where y is 5. So it's where y equals 5, or the point 0, 5. Okay, and then again on Desmos, you just click. I know my zeros. I know my y-intercept. There you go. So it's at the point 0, 5, which I have written that on my nifty paper right here. There we go. So I got my zeros and I have my y-intercept. Okay, and I'm going to label it on my graph. So this right here is my y-intercept, but be careful because the maximum is really close to the y-intercept. So be careful. Okay, and it'd be nice if my screen would stop freezing. Okay, so that's my y-intercept. Now, again, my graph is facing downward. Also, my a value is a -3, which means we're going to have a maximum. So I don't have a minimum, so no minimum. All right, let's find our maximum point. Okay, so to find my maximum, second trace. I'm finding a maximum, so I need to click 4 or scroll down and hit enter. All right, I need to go to the left of my maximum. To get my spider guy over, hit enter. I need to go to the right of my maximum, hit enter, and hit enter. So my maximum is at the point -0.17, so -0.17, comma, 5.08. There we go. Okay, and again, on Desmos, got my zeros, got my y-intercept, and here is my maximum. So if you guys see again, Desmos is a little quicker, but again, if you like to use your graphing calculator, I'm not going to say you can't. Okay, so I now have my point for my maximum right here, -0.17, 5.08. So this right here is the maximum. All right, so now we need to find the end behavior. So that's when you ask yourself, where do the arrows point on the left side of the graph? And where does the arrow point on the right side of the graph? Or as x approaches negative infinity, where does f of x head? And as x approaches positive infinity, where does f of x head? So on the left side of the graph, here are my arrows. This is the right side. All right, on the left side of the graph, where as x approaches negative infinity, where is your arrow pointing? Well, it's pointing down. And is that a positive or negative direction? Holy hot dog, that is negative. So we're heading down, which is a negative direction, which would mean f of x is headed to negative infinity. All right, then we ask yourself, what is the graph doing on the right side of the graph? Well, on the right side, it's also pointing down, which means it's headed in a negative y direction. So it's headed down. So f of x is approaching negative infinity. All right, so for the intervals of increase and decrease. Okay, so again, you trace from left to right. And remember, the dividing line is where your maximum or minimum point is. So my dividing line is where the axis of symmetry will be. Okay, so I personally like to start on the left. Again, it deals with the x value, so I need to look at the x value in my maximum point. So I know that both of these are going to be like x, and they're either going to be greater than or less than -0.17. So I'm going to set it up. Okay, so if we are to the left of this line, are these numbers on the x-axis to the left, are they larger or smaller than -0.17? Holy hot dog, you guys. They are smaller than -0.17, which means they are less than. Okay, so we know the values to the left are going to be less than. All we need to figure out, well, is the graph increasing or decreasing on the left? So on the left, as I trace, I'm heading upward. So what do you guys think? Am I increasing or decreasing on the left? I am increasing. You guys are so smart. So I'm increasing. Okay, so the values that are to the left of my line are increasing. And these are the values that are less than -0.17. So the interval increase is less than. Okay, so that means the other one's going to have to be greater than, because one of them is always greater than, and one of them is always less than. But I'll show you still. And again, you guys, you can do that on Desmos. You go to Desmos. Here, I'm going to type in my dividing axis of symmetry equation, which is x equals, it's going to be a little tricky, x equals -0.17 or so. Okay, and then remember, if you want to check yourself, well, this is where the graph is increasing, so I need to make sure that my inequality is shading on that side. So we said x was less than -0.17. And if you guys see, whoa, look at that. It is shading over the part of the graph that is increasing. So we did it right. Yes. Okay, and then the other half of the graph, we are headed down. So what do you guys think? Is the graph increasing or decreasing? So on the right side of the graph, it is decreasing. Okay, so are these x values to the right of this line, are they larger or smaller than that negative 0.17? What do you guys think? Well, like 4 and 6 and 8 are definitely larger than negative 0.17, so they are greater than. And just to double check yourself, if you want to change it to a greater than, it should be shading the correct side of the graph. Which, look at that heavenly hamburger that is shading on the correct side of the graph. So we did it right. Guys, so on the right side, it will be decreasing, and those are the x values that are greater than negative 0.17. So I'm going to write that on my paper, which I already did. Okay, so one of these will always be less than, and one of them will always be greater than. It just depends, well, is it increasing or decreasing on the left or right side of the graph? Okay, so this side was headed down, which means it's decreasing. All right, and then the x values that make the graph head down are these over here, which these are the values to the right of that line, which means these are the values that are greater than negative 0.17. All right, and the last step is our domain and range. Domain is how far left and how far right the graph goes. Okay, which since the graph gets wider and wider, it's going to continually go to the left and right. Okay, so that means all the x values are going to be used, and our domain will be x is all real. Which don't forget, for parabolas, your domain is always x is all real. All right, then your range, you asked yourself, those are the y values, domain is the x. Okay, so for the range, you asked yourself, how low does the graph go? How high does it go? So how low does it go? Well, these arrows means that it's going to keep heading down for forever. It's going to keep going down. Let me try to focus this better. Okay. Okay, so it's headed to negative infinity for forever. And then how high does it go? What is the highest y value on the graph? Well, that would be the y value at the maximum, which is 5.08. So I know it's going to involve the 5.08. Now, are these numbers larger or smaller than 5.08? What do we think? Man, you guys are so smart. They are smaller than 5.08. So these numbers are less than 5.08. And don't forget, since we have a solid point at our maximum, it can equal it. So y is less than or equal to 5.08. And don't forget, for your intervals of increase and decrease, we don't put an equal to sign because at that maximum point, that's where it's changing from an increase to a decrease. So the graph's not really equaling that point, okay? All right, well, that's it. Don't forget to name your graph something awesome. My graph's name is Margaret. It looks like a Margaret, doesn't it? Well, anyways, nice job, you guys. That's how you find all of these lovely key features on your graph by either using a graphing calculator or Desmos. Nice job, everyone.